In this video, we are going to look at section 1.5 from your book on quadratic functions. This first box here on our notes tells us how to graph a quadratic function. To find the vertex, well, first, we must have the equation set in the form where it's f of x equals 0 equals ax squared plus bx plus c. So you set this function equal to 0, so all of the terms are on one side of the equation. Then your a is your number in front, or your coefficient of your x squared term. Your b is your coefficient of your x term, and your c is the constant term all by itself. Now, if you take a negative b over 2a, that'll give you the x coordinate of your vertex, and then plugging that in will give you the y coordinate of your vertex. To find the axis of symmetry, it's simply x equals whatever that x coordinate was, or x equals h. Your axis of symmetry is a line. So when you find that value, you're going to write x equals that to indicate it's a vertical line. Then to find the x-axis intercepts, you set the equation equal to 0 and solve by either factoring the quadratic formula or completing the square, and that will give you your x-intercepts for the quadratic function. Now, sometimes a parabola will float above the x-axis and open upwards, or below the x-axis and open downwards, in which case you will not have an x-intercept. However, you always will have a y-axis intercept, and that is the number c from up here. It's 0, c. And then you'll find a couple other points, and that'll help you graph your quadratic function. Let's give this a try in example 1. Here it wants us to find the vertex, the axis of symmetry, and the maximum or minimum, and then graph the function. Make this a little bigger. So our function is, we do have all the terms on one side, so we can say that the a value here, the coefficient of x squared is 1, your b value here is 10, and your c is 23. So using that formula where we find our vertex, we're going to find the x coordinate of our vertex by taking a negative b over 2a. So in this case, that'll be a negative 10 over 2 times a, which was 1. That gives us a negative 5. So if that's the x coordinate of our vertex, we simply plug that in for x to find the y coordinate. So f negative 5 will be a negative 5 squared plus 10 times negative 5 plus 23. That'll give us 25 minus 50 plus 23, which is negative 2. All right, so now we know our vertex is a negative 5, negative 2. We found the vertex. Now let's find the axis of symmetry. The axis of symmetry is always the line x equals the x number here, so negative 5. That is our axis of symmetry. We don't just write negative 5 because it's not a number, it's a line. So here's the axis of symmetry. Now we determine whether this is a minimum or a maximum value at our vertex. Well, since the coefficient of x squared is a positive a, we know that this is a parabola that opens upwards, so this vertex is a minimum. And now we want to graph this. So we're going to give a very brief, quick sketch of this. All right, I redrew the graph so we could try to fit it on our sheet here. Now we know our vertex is at negative 5, 2. So 1, 2, 3, 4, 5. Negative 2 is right here. The axis of symmetry is the vertical line that goes through there, so it's not part of our graph, but it helps us graph the function. We know that our y-axis intercept is 0, 23, because it's that constant c. So if this is 20, 23 is about up here. Now, I did not calculate the x-intercepts for this one, but we can go ahead and try to graph it as it is. And it's going to look something like that. Lovely. All right, let's skip to example 2, where once again it asks us to find the vertex, the axis of symmetry, minimum or maximum value of x squared over 2 minus 4x plus 8. So first we identify our a, b, and c. In this case, our a with x squared over 2 would be the same as 1/2. Our b would be -4, and our c would be 8. Go ahead and calculate your vertex and neat back up. So when we substitute in -b over 2a, we get the opposite of -4 over 2 times 1/2. This, of course, makes a +4 in your numerator, and 2 times 1/2 is the same as 1. So if you have 4 over 1, you get 4. Substituting 4 into your equation for f of x then gives you 0 for your y-coordinate. So we know that this is our vertex, the point 4, 0. Now, because the coefficient of a, or the coefficient of x squared, our a here is positive, once again, it opens upward, so 4, 0 is a minimum. Let's look for our axis of symmetry. You know from above that when you find the axis of symmetry, it's the vertical line that goes through your vertex. So in this case, the equation of my vertical line will be x equals 4. Then let's see. Oh, another thing we know is that since this constant number 8 out here has no variable with it, that is our vertical y-axis intercept. So our y-intercept will be 0, 8. So let's go ahead and graph this and check it together. Give it a try. So here we've identified all of those parts of our parabola. We have our y-axis intercept at 0, 8, our vertex at 4, 0, our axis of symmetry at x equals 4. And since we know it's an axis of symmetry, if 0, 8 is a point on my parabola, then if I go 4 units to the right of the axis of symmetry, I would know that 8, 8 would also be a point on my parabola. One helpful use of the axis of symmetry. Let's take this a little bit further and try it again. So here we have our formula for finding our vertex again. So we want to find the vertex, determine if it's a maximum or minimum. We want to find the range, and we want to identify where the function is increasing and decreasing. I'm going to ask you to accomplish part A, part B, and graph it, and then part C, and then we'll look at them together, and part D together. So here we would find that the vertex is 7, 2, check the math on that. And then because A is a negative value, you know the parabola opens downward, so 7, 2 is a maximum. Drawing a primitive graph of this, my vertex being 7, 2, and the parabola opening downward will help me find the range. So range is the y-values of your function. You can see that this parabola is going to go on down to -infinity, and that the maximum value this parabola will meet is a +2. So my range is a -infinity to 2 with a bracket at 2. And then on what intervals is the function increasing and decreasing? When we list intervals of increasing and decreasing, we do that in terms of x. So my parabola here is increasing when you go from, kind of like think of slope. So here on this side of the parabola, it's increasing. So it's increasing to the left of x equals 7. X equals 7 at the max. The left of x equals 7 means from -infinity to 7. So notice I'm not putting the y values. I'm noting the x values where my y values are increasing. Similarly, when we look at decreasing, let's do that in purple. We're looking at where the slope of this graph is negative, and we want to identify the x values where it is decreasing. So we'd say it's decreasing from 7 to +infinity, because We're not listing the y values, we're listing the x values where the y values are getting smaller. All right, in our next video, we will cover some concepts from section 1.6. Thanks for watching.